So, due to N1, so what is the cumulative fatigue damage here? So, here cumulative fatigue damage we can find out that cumulative fatigue damage we can write as D1 plus D2. So, here D1 already I have told you that is 0.33, and for this sigma 2 stress level another fatigue damage we are getting, that is 0.5. So, this will be equal to, you can say, 0.83. Again this is also lesser than 1. So, what happens here, after damage tally what we observe, that this case also no failure is occurred. What I am telling, understand? Now, if we further increase another number of cycle, let us what happens, this higher stress level sigma 2 instead of 2 number of cycle, if we use sigma 2 equal to 3 number of cycle, for this case what will be the overall damage. So, that I am showing here. So, here for N2 equal to 3, here D2 will be what? D2 will be generally we know for N2 where the higher stress level sigma 2, for this higher stress level sigma 2 we know capital N2 equal to 4, already it is given, we calculated from SN curve. Okay. So, that we can easily see. So, here N2 capital N2 equal to 4, for this case generally D2 will be 3 by 4, that will be equal to 0.75. So, in this case 2, what we can write, in this case 2 your total damage, that means here you can write summation of D will be your DI will be your D1 plus D2, this will be equal to, you can say, 0.33 plus 0.75 will be 1.08, which is greater than 1. So, what happens here, failure has already occurred. So, for this case failure will be occurred. This way generally summing up the damage proportion we can find out whether this structure is subjected to further number of stress cycle or not, that we can easily find out. Okay. So, this is the concept of generally Palmgren's Minard's rule. Now, we will solve some problem little bit step by step, then it will be more clear to you. So, let us consider this is a problem statement. So, here detail step is given. So, here then you will get overall idea how to use this Palmgren-Minard's rule for finding out the life cycle or finding out the damage proportion, that we can easily find out. So, here generally what are the problem statement is given, 2 steel plates of 16 millimeter thick are butt welded. So, this is one plate, you can see in figure it is given, figure number 1 it is given. So, it is butt welded, here generally it is butt welded, you can say here butt welded, which is subjected to completely reverse bending stress. So, here it is given, it is subjected to reverse bending stress. So, reverse bending stress if it will be, so in marine equation then you can say Ke should be equal to 1, for reverse bending stress Ke equal to 1. We know for axial reverse axial stress you can say Ke equal to 0.85. Similarly, for reverse torsional types of stress this Ke value is different, that is around 6 or 0.59 sometime it is considered. So, it is subjected to completely reverse bending stress, consists of following 4 elements. So, it is subjected to different stress level of different proportion is given. So, you see like here this bending stress 250 MPa for 60% of total life. What I am telling, understands? So, here 60% is equal to alpha 1. So, alpha 1 will be equal to 0.60. Here instead of what is called number of cycle, here it is given its total proportionate of time. So, alpha 1 is given. So, plus minus that means 350 megapascal for 20% of time, then another stress level 380 megapascal for 10% proportion of time, then 400 megapascal for another 10% of time, total 100% of its total life generally it is given different stress level. So, here the material component is made up of 45C4, one types of steel material nomenclature it is. It has the ultimate stress is given as 500 MPa. So, what we need to determine? We need to determine the endurance strength and fatigue life of the component before failure. So, here generally the other information given as notch sensitivity factor Q equal to 0.88, surface finish factor of that component is given as of this joint configuration is given as 0.85, size factor is given as 0.8 and expected reliability factor Kc is given as 0.868, what I am telling, and these are the information is given. So, based on this information we need to do generally what are the things we need to find out? We need to find out what is the N, that is total life, total fatigue life of this component. What is this? This we need to find out. Another things, that is your AC, that is endurance strength. Endurance strength of this component also we need to find out. These two we need to find out. What are the information given? Here the information given is, so given whatever the data is given, based on this given data we will solve this problem. So, first of all, here generally thickness of the plate T, let us this T is the thickness of the plate, is given as 16 millimeter. Then we have here eccentricity between this, here generally this two plate, it is subjected to some eccentricity E, that is equal to 2. So, here eccentricity equal to 2 millimeter is given. Okay. Now, based on this information, eccentric types of joint, we know we can easily find out what is the theoretical stress concentration factor. Theoretical stress concentration factor. So, for eccentric types of weld joint, I have already told you, generally this Kt we can calculate as this Kt equal to, you can write as 1 plus 3 into eccentric distance between two plate neutral axis, distance between two plate neutral axis, that is 2 millimeter already given, divided by T. So, this will give us 1 plus 3 into 2 divided by thickness of the plate is 16. This will give us a value of 1.33. Because for endurance strength calculation purpose, these are the things will be required. Now, we know Marine equation which is used for endurance strength calculation. So, Marine equation generally we know that endurance strength of this component will be different, modifying different types of what is called factor, that is Ka, Kb, Kc, Kd, Ke, Kg into 0.5 into ultimate strength. We know this formula, Marine equation. So, I am not going further to explain these things. So, here Ka is given as 0.85, you can see Ka is given as 0.85, Kb is given as 0.8 is given, Kc is given as 0.868, that is reliability factor, you know this thing 868, because we have solved these types of problem earlier times also. Here thermal effect we have not considered, that is why Kd we consider as 1. Here K is load factor, already I have told you as it is a reverse types of bending stress, this welded joint is subjected. So, here K is also 1, but Kg you know this should be equal to 1 by Kf. What is Kf? And another things also is given, this is 0.5 into 0.5 ultimate strength is given as 500 MPa. So, 500 MPa I am writing. Okay. So, what is Kf? This Kf we need to find out. So, Kf generally Kt is known, theoretical stress concentration factor is now known, which is actually 1.33 is I have already calculated based on this formula. Okay. Now, what happens? We have given generally this Q equal to given Notch sensitivity factor Q equal to given as 0.88. So, based on this Q value, what we can calculate? We can calculate Kf value. So, Kf generally we can calculate, which is actually 1 plus Q into Kt minus 1. So, this formula is also known to you. Okay. So, based on this formula, what we can find out? Actually this value is coming, Kt is equal to is coming as 1.375 actually. So, this I am just putting here, that is 1 point Q in Q is what? Q is 1.375 is Kt. So, Q is generally 0.88 and Kt is 1.375 minus 1. If we put these things here, we will get Kf is equal to 1.33. This, so, Kf we are getting based on this Kt value, which is 1.33. This we need to use in a Marine equation for endurance strength calculation. So, here this Marine equation I am writing equation number 1. So, in equation number 1 we need to find out, put Kf is equal to 1.33. So, everything is known in this Marine equation, that is equation number 1. So, if we put this thing, because we know that Kg is equal to 1 by Kf, that means that instead of Kg I have written 1 by Kf here. Okay. So, if we is now in this equation number 1, everything is known. So, based on these things, we got this endurance strength value, which is actually equal to 110.947. This you should keep it in mind. This is in MPa, megapascal, or you can say 1 megapascal is 1 Newton per millimeter square. So, you can directly write Newton per millimeter square also. So, based on this Marine equation, what we got? We got endurance strength value. So, one solution we got. So, endurance strength AC, this is also one of the answer asked by this question. That is why endurance strength AC equal to, you can write as 110.947 MPa. Okay. This is our own solution we have already got. Now, for this different stress level, that is, this is your sigma 1 stress level, sigma 2 stress level, sigma 3 stress level, sigma 4 stress level is given. So, based on this stress level, we need to find out what is the number of cycle, and its proportionate is given, number of cycle we need to find out. Okay. That I am just going to show. Now, what happens? Now, we need to first find out what, for finding out the what is called capital N1, capital N2, capital N3, first of all we need SN curve. So, now we will discuss how to construct SN curve. So, I am writing construction of SN diagram, it will be diagram. How generally we can construct the SN diagram. For this generally what are the things required? We know for SN curve diagram, what are the steps I have already told you. Generally for SN curve diagram we need log 10 AC for 10 to the power 6 cycle if it is a steel plate. So, log 10 AC is generally here it will be log 10 endurance strength I have already calculated, that is 110.947. So, this will give us a value of 2.045. Okay. Now, another point is another value is required in case of SN curve, that is log 10.9 ultimate strength, you know. So, log 10.9 ultimate strength is 500 MPa is given. So, this will give us a value of 2.6532, 2.6532, what I am telling, understand. So, based on this information, what we need to do? We need to draw the SN curve. So, this SN curve I am drawing here. Okay. So, this SN curve I will draw, then it will be very clear to you how generally we need to draw this curve. So, SN curve generally we need to draw for horizontal axis represent log 10 number of cycle, and this vertical axis represent log 10 fatigue strength. So, here first of all this A point we need to find out. A point is what? A point you can write as 3 comma log 10 0.9 ultimate stress, you know these things already I have explained, and we need to define another point, that is our B point, that is actually 6 comma log 10 endurance strength. After that, what are the things required to do? We need to draw this AB point by drawing a straight line. This AB point is generally we joint. Now, so you see, so in this A point, this is our 3 in log 10 curve, this is our 6. Okay. So, this is our A point, this is our B point, already you know. Now, what are the things required to do? We need to corresponding to a particular stress value, this is your A stress value, what is called log 10 sigma, corresponding to a particular stress value, that point is E. Okay. We need to draw a horizontal line, and this horizontal line, corresponding to this horizontal line we need to draw a vertical line which is parallel to this, you can say ordinate. So, corresponding to these things, whatever the number of cycle you will get n, that will give you the fatigue life of a stress level sigma. Let us consider this is sigma y, this is capital Ni. These are the things you should keep it in mind. Okay. So, let us consider this E, this horizontal line from E, if we draw, it cut this AB line at a point that is called F. Okay. Now, another line I am drawing, that is parallel to this, you can say abscissa through point B, which cut this ordinate at point C. Okay. So, this is the what it is called, this is the SN diagram, this is the SN diagram. So, how the SN diagram is plotted? For SN diagram plot purpose, we need generally 2 point A and B. Based on this A and B, how generally this A and B is coming, that also I have told you. So, we can easily find out what is SN diagram. From this diagram, what are the things we need to find out? Corresponding to different stress value sigma I, we need to find out what is the capital N value. that means capital Ni value. These are the things you should keep it in mind, that I am going to show now. So, first of all, what we will do, from the similarity, from the similarity of two triangle, that is triangle A E F and another triangle A C V, from these two triangle, from the similarity what we can write? We can write E F divided by, you can say, C B is equal to, we can say, AE line divided by AE divided by AC. This you can easily get actually. AE is this, AC is a bigger triangle. Okay. From this what we can write? EF equal to, you can write as CV into AE divided by AC, correct. Now, everything is known. What is CV? CV, you see, CV is 6 minus 3, always you should keep it in mind, this is not 0, this is not 0, okay. This is 3, okay. These are the things you should keep it in mind. So, it will be CV is 6 minus 3 into, what is AE? AE is given as, A is given as how much? Already I have shown you 2 point, A is 2.6532 and this log 10 sigma I is your E divided by, what is AC? AC you can get, A is given as 2.6532 minus, C is also given as, C is given as log endurance strength. This C is given as log endurance strength is 2.045, already I have shown. So, this if you just do some calculation, what are the things you will get? This will give us 4.9326 into 2.6532 minus log 10 sigma I, okay. Now, based on these things what we can get? We can get EF value. So, EF value is now known to us. What is EF value? So, what we observed that from this general we got EF equal to 4.9326 into 2.65, this, let us consider this is equation number 2. So, this EF from this diagram, that means from SN curve, EF we can write as what? Log 10 n minus 3, this we can write. So, from equation number 2 what we can get? From this equation what we can get? So, log 10 Ni minus 3, this should be equal to, you can write as 4.9326 into 2.6532 into log 10 sigma I. Okay. So, from this from here what we can write? Log 10 capital Ni equal to, we can write as 3 plus 4.9326 into 2.65 log 10 sigma I. Let this is equation number 3. Okay. Now, in this equation for different sigma value we will find out fatigue life of that component. Like for sigma 1 for I equal to 1 you can write, for I equal to 1 sigma 1 equal to 250 is given, MPa is given. So, putting the value of sigma 1 equal to 250, put in equation 3, equation number 3, we will get sigma 1 corresponding to N1. This we can easily find out. This N1 value is coming as, directly I am just telling, instead of putting this thing again and again, I am just directly putting what is N1 is coming directly, that I am telling, that will be better. N1 is coming as 18146.8, 18146.8 number of cycle. Now, for I equal to 2, that is sigma 2, which is given as 350 MPa, this put in equation number 3, what is N2 we got? N2 we will get that is equal to your 3452.6, 3452.6. Okay. Now, for I equal to 3, sigma 3 equal to 380 MPa, this will give put in this equation number 3, we will get N3 equal to how much? N3 we are getting 2301.72, 2301.72. Okay. Now, for I equal to 4, here sigma 4 equal to 400 MPa is given. Okay. Put this value in equation number 3, what we will get? N4 we will get as 1786.72, 1786.72. Okay. These are the number of cycle generally you can calculate by this SN curve using this equation number 3. Okay. Now, we know in this problem it is given the 250 MPa is for 60% of time, then 350 MPa is 20% of time, and 380 is 10% of time, and 400 MPa is 10% of time. So, here you can say alpha 1 is given as 60%, we can write this equal to 0.6, alpha 2 is given as 20%, that equal to you can write as 0.2. Okay. Corresponding to these things you can write as, corresponding to these things you can write as alpha 2 you can write as 0.2. Similarly, alpha 3 is given as 10%. So, alpha 3 corresponding to you can write as 0.1, and alpha 4 is again 10%, that also you can put as what is called 0.1. Now, from Minard's equation for proportionate of time we know that is alpha 1 by capital 1 plus alpha 2 by capital N2 plus alpha 3 by capital N3 plus alpha 4 by capital N4. Okay. This should be equal to 1 by capital N. This is capital N is the total number of cycle which we need to calculate. Okay. This N actually we need to calculate. This you should keep it in mind. So, now I am putting these things in this equation, that is alpha 1 is given as 0.65, n 1 we got as 18146.8 plus alpha 2 is given as 0.2 divided by 3452.6. Okay. Alpha 3 is given as 0.1 divided by 2301.72 plus alpha 4 is again given as 0.1 divided by 1786.72 divided equal to your 1 by n. So, from here you can easily find out what is the n value. Okay. So, this way generally we can easily find out what is the total life of a component like a butt welded joint, which is subjected to 4 different types of stress levels, sigma 1, sigma 2, sigma 3 and sigma 4. Then what should be its total fatigue life. So, this is the technique by which you can find out the total fatigue life of a structure, as well as by this Minard's equation. Generally what are the things we can calculate? We can calculate the cumulative fatigue damage of that structural component, and we can say whether further this structure is able to subject some further loading cycle or not, that also we can say. And when it will be failed, that related things also you can calculate with the help of this Minard's rule, that is Palmgren-Minard's rule. So, next lecture I will discuss about once a structure subjected to fluctuating types of loading instead of reverse types of loading, then how to estimate the fatigue life and how to design the fatigue component, fatigue life related component, that I will discuss. So, these are the references which I have followed for this lecture. Thank you.